A wrecked mobile crane on its way for repairs after a heavy crash at a shipyard in the south of Sweden with large material damage as a result. Before, it was impossible to repair or align all parts of a crane in a reliable way. New technology has made this possible. The accident happened at the docks when the crane was lifting a small boat. The boat did not have a bottom plug and was filled with water. The crane driver tried to save the boat from sinking, which was now several times heavier. As the supporting legs of the crane were not in position, the crane overturned. To make sure that all parts of the damaged crane shall be repaired properly, it is important to estimate the amount of damage at the scene of the crash and how or why the accident occurred. It is important that the cause of the accident is clarified so that any technical faults can be adjusted on any similar cranes with the same construction. Driver error or misuse can be avoided if information about the accident is given to the crane driver and people in the business. SA, together with the insurance company, Steelworks, Yosam, and Professor Stenborg, have worked out recommendations for eventual repairs on the cranes. Cranes are sent to Yosam for repairs. First of all, the garage personnel make out a report on the actual damage and any other possible defects such as endurance cracks and worn-out parts. An estimate of possible reparation should be made together with the crane owner, insurance company, garage owner, and SA. The garage must have a certificate of competence set by crane standards to perform the necessary repairs. The garage must also have access to licensed welders. An accurate account of the reparations must be made. Yosam uses this kind of form. Walter Heinrich is one of the enthusiasts in the project. He has experience as a crane constructor and has worked at SA since 1977. He has also worked with Stenborg, the legendary professor in material science at the Technical College in Stockholm, who is a great inspiration. It is because of the help, advice, and instructions of Stenborg that we are able to take steel, align, and adjust it. As an SA member, are you nervous that this failure will repeat itself? No, as we are poking around with the crane beam anyway, we might even detect other deficiencies. I think a lot of the crane beams are better now than when we started, and others will be just as good. Is this just the beginning, or are they going to be developed even more? Yes, I think so. We have set our margins so that we can clear safety limits without taking any chances. Anyhow, as development progresses and we have more experience, we will be able to raise our goals and start on more complicated parts. Here we have what appears to be a simple defect, but it is in fact quite complicated. We have here from the beginning a manufacturing deformation, this bulge in the corner. It is superimposed on the breakdown deformation here and is to be aligned later. In this way you destroy the material even more. This means that the sum of the two deformations is quite large. You have in general two possibilities. One is that you cut out a plate and weld it with a butt joint. One can use a backing bar. You have it on the underside of the beam. These supporting rollers are on that side. The other possibility is that you do a material test at the end of the beam where there isn't so much tension. Deform it and test its resistance on impact. With this sort of test, you can see if there are enough material properties left for a safe construction.
då kan man se med det slagsäkerhetsprovet om det är tillräckligt mycket utav materialets egenskaper kvar för att man ska få en betryggande konstruktion.
This is an example of a beam where they are welding in new plates. The new plates are given the same treatment as the deformed parts from original plates to a fully repaired beam, eventually including heat treatment. After that, an impact and tension test is done. A plan for repairs is established, including drawings, material specification, welding plans, and specifications on replaced parts. The repair plan is shown to SA before the job begins. Here we have TIG welding in process. There can be defects caused by welding. The quality of the welding is increased by the TIG welding. Eventually, pores can come to the surface and cracks can be melted away in the transition zone between the weld and the base material. Grinding is done after welding. It is important that the grinding scratches go parallel with direction of force in the beam. The sketch shows the grinding direction. Alignment is accomplished with the help of jacks and inductive heating. It is important that temperature is kept within the material for a suitable interval. The hardening process should not be damaged where there is a lot of tension. Stress-relieving anneal is performed on a few parts after alignment or welding. It is important that heating speed, temperature interval, and holding time have the right values. Careful tests must be done after repairs. Magnetic tests, ultrasound, or as we do here, X-ray. Here we have an X-ray photo that must be examined and graded so that welding can be approved. How is it with just this sort of crane? Is its steel good for repairing? Yes, it can be repaired. Here you have some damage caused by the accident and damage caused by endurance failure. This crane has been used before as dock crane and has been quite heavily loaded. Not overloaded, but just in intensive use and has had too many various loads. Here we have some damage in a low-bearing area. That's why a higher temperature can be used, even if the hardening gives a negative effect. Have we made the most progress in Sweden concerning the alignment of cranes? Yes, and that is partly due to the fact that Yosam, who is with us now, has aligned truck frames. They have developed a method with inductive heat, which is very good, and with that you can steer the heat flow quite accurately. As a result, you get small heated parts where required. One can also achieve accurate temp control without damaging the hardening process in the crane beam. On the contrary, the end result is excellent. The crane beam is placed in an alignment bench where one can simulate loads and conduct measurements where plastic deformations can be discovered. Here we have a crane beam which has been repaired and is definitely straight. They use a laser to get every little deformation. They set the laser instrument on the various measurement panels and in that way ascertain where deformations appear. After that, you do some more alignment operations to get a nice straight beam. The beam should not bend sideways without any load or with just a vertical load. Wind load or inertia start-stop will naturally give sideways deflections, but after unloading, the beam should be straight again. We have not only deformations from the accident, but also endurance failure, which is very serious on this crane. This is the backside of the beam, which goes in the next part and has very large cracks. The attachment for the hydraulic cylinder is here, and also for the backing roller. It's completely cracked on both sides. If the crane had not crashed on account of the boat, it would have definitely crashed after a short period of time anyway. One can only establish that these cracks are a construction fault.
De här sprickorna, de kan man nog konstatera att det är ett konstruktionsfel. Och det man ska göra här.
The thing to do here is to partly reinforce and cut away this plate while replacing it with a thicker one. Support this on the front side, hold it together so that it can't move. Now you get a strutting that will also hold the cylinder in place.
Och då får man en förstyvning som håller cylindern på plats också.
Here we have another serious defect. This beam is lying upside down. Here are the front supporting rollers. It is at the front edge of the beam and in the closing position that the supporting rollers come forward. This means that the front parts can be examined while the parts behind the supporting rollers cannot be examined. Here we have a crack this long and is due to endurance failure in the beam. The supporting rollers have mangled the beam and deformed it. Deformation, plus the cracks, would have eventually led to breakdown anyway. This is due to the fact that the beam is undersized in respect to the supporting roller's pressure. It is because we dismantled the beam that the cracks were detected before there would have been a breakdown. At breakdowns, it is common that very high loads are transferred by the slew ring and the connection screws. Screws that loosen often change character in such a way that they obtain an adequate clamped length. Washers with the right hardness must be assembled on both sides in a resistance bolted joint. The tightening moment, clam length, and the hardness of the washer are vital for its strength. Who benefits from this? Everyone does. The insurance company pays less for a repair than a new part. In the long run, this means the insured, the crane owner, gets a lower premium. The crane manufacturers also feel that their cranes are repairable. Instead of sending the crane to the manufacturers and having to wait a long time for new parts, it can be taken to a garage and be repaired. The crane can be back in work again after a short time.
Leveranstid på den nya biten, så kan han dra in den till en verkstad och få den reparerad, och kranen kan vara i drift igen efter relativt kort tid. Stillestånd.
When the crane is ready, it has to be given a last inspection and check loading, which is done by SA if possible, together with a representative from the garage, the owner, and the insurance company. A crane repaired by this method retains perfect quality and safety in accordance with crane standards.